So this is the second part of the lesson, video number 2 on the quadratic formula and the discriminant of the quadratic formula. Yesterday, we focused in on simplifying radicals. As you can see, all these questions we did, it was just simplifying them. You could do it with the calculator, but it's just as easy to do it by hand. I mean, for me it is at least. And you also have square root of negative numbers. And yesterday we reviewed that those negatives come out as imaginary values, right? And we also practiced pretty much doing the last step of the quadratic formula, where you have a fraction like this, and you could reduce all 3 terms by 2, right? So you can't really reduce unless all 3 terms could be reduced by 2. So we did that yesterday. If you need to see that, please go back and watch that video. Yesterday, we also went over the steps to applying the quadratic formula. Step 0, before using the quadratic formula, you got to make sure it's in standard form, set equal to 0. So ax squared plus bx plus c equals 0, or you could have a y equals ax squared plus bx plus c. But you have to have it like this for you to be able to identify a, b, and c. And then you could actually use the formula. But I say, step 1, replace the formula with parentheses. And it shouldn't be replace the formula, it should be replace the variables of the formula with parentheses. So you got to start out with this, and then you could plug in your values. And once you plug in your values, you begin by finding the discriminant, the inside of the square root. That's what you want to start with, okay? And once you find that number, then you could try to simplify the square root, maybe with a calculator, and you could then simplify the fraction, if possible, the way we practiced up here. So we did one example yesterday. I feel like doing that example over again just to get you guys in the right train of thought here. So number 1, if we look at the instructions on the bottom left corner of this page, it says, make sure that it's set equal to 0. So it's not set equal to 0. So you would start by adding 13 and adding 13. And now it'll be set equal to 0. You have x squared plus 8x plus 13 equals 0. And now what that means is you could identify your a value being 1, your b value being 8, and your c value being 13. Bless you, by the way. So now you can easily plug them in, right? So I always start with the b values, and the b value happens to be 8. So plug in the 8 right there and right there. And then plug in the a value of 1 right here and right there. And plug in the c value of 13 right here, okay? Now on the instructions, it says, after you plug it in with parentheses, I want you to begin by doing the discriminant. Now the discriminant is the inside of the square root, okay? So you're not gonna type in the square root. You could type that exact value onto your calculator with parentheses and all. If you don't use parentheses, it's very likely you're gonna make a mistake. So please type it in with parentheses like this. So the calculator could do the work for you. Just make sure you use parentheses and write it in exactly the way it is. So the answer of the discriminant, the value inside the root, is going to be 12, okay? So let's just understand that. Now, you didn't have to use a calculator. You could have done this on paper. So you could have said, well, what is 8 squared? And you could have written down 64 on the side just to keep track of what it is. And then you have minus 4 times 1, that's minus 4. And then times 13, that is minus 52. So you technically have 64 minus 52. And if you take that away, you end up with 12. But of course, it's easier on the calculator. Well, maybe. I mean, it does take a while to hit all these buttons and stuff. So, I mean, if you want to do it by hand, go for it. That's 12. But that's what you start with. You see, when you start with the discriminant, you end up with everything else, the minus 8 plus or minus. But now you have a nice, beautiful 12 instead of the discriminant expression of b squared minus 4ac. And you are dividing by 2 times 1 is 2. So there's your answer. However, it's not simplified yet. In other words, after you get your discriminant, then you try to simplify the radical. That's what it says down here. It says simplify the square root. After you do your discriminants, try to simplify the square root. And you could do the calculator to simplify the square root of 12, or you could also do it by hand, where 12 is not a perfect square number, so you rewrite it with multiplication to get a perfect square number. So that's why I'm writing it as 4 times 3, because 4 is a perfect square number, and if you split it, you'll be able to do the square root of 4, which is 2, and the square root of 3 stays the square root of 3. So we're going to replace the square root of 12 with that simplified square root, well, 2 square root of 3. So you replace it, you have a negative 8 plus or minus 2 square root of 3, and it's over 2. And for your final step, we're going to do what we practiced yesterday, where you have something like this and you reduce everything by 2, or maybe reduce everything by 7 or by 3. Reduce everything by whatever you can. And in this case, we could reduce everything by 2. So negative 8 divided by 2 is negative 4. 2 divided by 2 is 1. 2 divided by 2 is 1. So our final answer will be negative 4 up on top, plus or minus. Now, you don't have to write a 1 in front of the square root of 3. It's like you don't have to write a 1 in front of an x. That's just 1 square root of 3. So you could just write square root of 3. And you definitely don't have to do the divided by 1, because anything divided by 1 ends up being the same thing. So that's why the divided by 1 is not necessary. There's your final answer right there, okay? Now, believe it or not, that is technically 2 answers, okay? X equals negative 4 plus square root of 3, and x also equals negative 4 minus square root of 3. That's 2 answers. So we did that yesterday, and today we're going to focus in on questions 2, 3, and 4, which are all quadratic functions, quadratic equations, and we're going to solve them all with the quadratic formula, even though there's other methods of solving, but we're going to practice the quadratic formula, and we're going to be able to conclude some things about the discriminant. So I'm going to move to this other slide. Let's start with number 2. Okay, so we want to begin by solving, of course, by making sure it's in standard form set equal to 0. And as you can see, it's not set equal to 0. So let's all begin by subtracting 32, canceling out. Now, yes, you have the equal 0 now, but you can't really do 14x take away 32. You got to rewrite the whole thing. So you're going to write x squared minus 14x minus 32 equals 0. And now that it's in standard form, set equal to 0, now you could identify the a value being 1, the b value being negative 14, and the c value being negative 32. And now what we do is we plug it in, this first step, plug it in with parentheses, right? So what we're going to do is rewrite the formula, but with parentheses. And we're going to plug in the a, the b, and the c. So let's begin with the b values of negative 14 right there and right there. Plug in the a value of 1 right there and right there. Plug in the c value of negative 32 right there. And again, according to the notes, it says begin with the discriminant. So you're going to begin with this inside value. Let's do it on a calculator. That'll be easy. If you carefully type it in with parentheses and all, it doesn't work for you. You get 324, and that is the discriminant, 324, okay? So what I'm going to do is rewrite my actual math here. I have a positive 14. That's 14 plus or minus. I have the square root, but notice I did a small square root because I'm not going to do this whole thing. I'm going to plug in that answer, 324. 324 is the discriminant, okay? And it is over 2 times 1 is 2. So after you simplify the discriminant, then you try to simplify the square root. And again, you could use a calculator. Try to simplify this guy with the calculator. Again, the square root button's right here. Type in 324, hit equal, and you do get a nice, beautiful answer. 324 is actually a perfect square number. So we get 18. So in reality, we have 14 plus or minus 18 divided by 2, okay? Now that plus or minus produces 2 answers, okay? So what do I mean by that? You got to do both. You got to do the 14 plus 18 divided by 2, and you also have to do the 14 minus 18 divided by 2. The plus or minus means that both have to happen, 14 plus 18 and 14 minus 18. And if you do both of those, you're actually going to get 2 answers. 14 plus 18 is 32 divided by 2. That is 16. And 14 minus 18 is negative 4 divided by 2, and that's negative 2. So our answers to this quadratic trinomial equation in standard form is x equals 16 and also x equals negative 2. So we get 2 answers. Sound good? All right, so let's move on to this next one, number 3. It says find the roots. It doesn't matter if it says solve, find the roots, find the x-intercepts, find the real zeros. find the answers. They all mean the same thing. So find the roots. You're going to set the y equal to 0 and solve. And again, you could do this other ways, but we're practicing the quadratic formula. So let's begin by rewriting our quadratic formula. The quadratic formula is right here. Negative b plus or minus square root of b squared minus 4ac all divided by 2a. And we're just going to write this part with parentheses right here, okay? And we're going to plug in the a value of 1, the b value of negative 4, and the c value of positive 4. So let's start with the b value of negative 4 right there and right there, the a value of 1 right there and right there, the c value of 4 right there. And of course, the notes say begin with your discriminant. So the inside of the square root, what's that going to be? So you could do this with the calculator. And if you type it in the way I did before with the calculator, your discriminant will be 0, right? And you're probably thinking, what? You just did that in your head? Well, yeah, I actually did do it in my head, because if you go negative 4 squared, negative 4 times negative 4 is 16. And over here, 4 times 1 times 4, that's also 16. So 16 take away 16 is 0. So our discriminant is 0. But then again, use a calculator if you want. The discriminant is 0. So you're going to rewrite this. Instead of minus minus, you're going to have a positive 4 plus or minus the square root of, we said the discriminant was 0 because 16 take away 16 was 0. Or if you did it on a calculator, it would give you 0. And it is divided by 2 times 1, which is 2. Now, think about this, guys. The discriminant is 0. And what is the square root of 0? 0, right? So when you simplify this square root, you really end up with 4 plus or minus 0 divided by 2. And that plus or minus means that you have to do both, adding 0 and then going back and subtracting 0. Now, when you do both, like we did above, 4 plus 0 divided by 2, and then you go 4 minus 0 divided by 2, is that going to give you different answers? No way, because if you add 0, it doesn't change. If you subtract 0, it doesn't change. So either way, 4 plus 0 is 4. 4 divided by 2 is 2. Right here, 0 minus, or 4 minus 0 is 4, and 4 divided by 2 is still 2. So the reality, question number 3 right here is x equals 2. There's only one answer. So on the top one, we actually got 2 answers. And on the bottom one, we only got 1 answer. Okay, now I want you to think about the discriminant on the first one. The discriminant was 324. It was a positive value, and that produced 2 answers. This discriminant that we did on the second one, which is question number 3, we got 0 as a discriminant, and adding and subtracting 0 doesn't produce 2 answers. It only produces 1 answer, because it doesn't matter if you add 0 or subtract 0, it's still the same number. Now let's move on to this next one, and we're also going to do the quadratic formula once again. And doing the quadratic formula, let's identify the a value. A value is negative 1. The b value is negative 3. And the c value is also negative 3. So let's begin with the b value, negative 3, negative 3, the a value of negative 1 and negative 1, and the c value of negative 3. Okay? So when you do the discriminant here, you could use a calculator if you want. Or you could just do it in your head or by hand, like 3 squared is 9. Negative 3 times negative 3 is positive 9. And you have negative 4 times 1, that's positive 4. Positive 4 times negative 3 is negative 12. So you really have 9 minus 12, which is negative 4. Now, if you did it on the calculator, it will give you a negative 4. So what you really have here is the minus minus becoming a positive 3. And we said that the discriminant was negative 4. So let me rewrite this. We have the positive 3 plus or minus the square root of negative 4. That's a discriminant, divided by 2 times negative 1, that's negative 2. So what's the problem here? We have a negative inside the square root. So right here on the side, if I do the square root of negative 4, I'm supposed to take that minus sign and move it out. Remember what we did yesterday? And that becomes an I. So you have I times the square root of 4. And then you could actually do the square root of 4 and get 2, and you have I times 2, which is 2i. Now, the calculator cannot do that for you. If you typed in this into the calculator, it's going to say error. So you actually have to do that by hand and then rewrite the 2i in place of the square root of negative 4. So your answer is 3 plus or minus 2i divided by negative 2. And this is your answer, because you can't say, okay, 3 plus 2i, because you can't add real numbers with imaginary numbers, and you can't go back and do 3 minus 2i, but it does produce this answer, and this answer is imaginary. In other words, it's not real, but this is an answer, okay? But it's not real. Why is it not real? Because it has the I involved. Okay, so I want you guys to think about what made it imaginary. What do you guys think? What made this one imaginary? The square root of a negative number. So when you have a negative number in here, that makes it imaginary. So I want you to conclude something here with these 3 examples that we've done. Question number 2, our discriminant, 324, that was positive, and it luckily was a perfect square number, but any positive number is going to produce 2 answers. Any positive number is going to produce 2 answers. Even if it were the square root of 7, because technically the square root of 7, even though you can't simplify it, it is a crazy decimal. And if you added that crazy decimal and then you subtracted that crazy decimal, it would produce 2 answers. So keep this in mind. If your discriminant is any positive number, it'll produce 2 answers. But if your discriminant is 0, well, it doesn't matter if you add 0 or subtract 0. You only get 1 answer that's the same answer, okay? And lastly, the most recent one, if your discriminant is negative, then you're going to get no real answers, okay? So that's what you need to conclude based off of these examples. Now, what does that really mean? Again, when you say 2 real answers on number 2, if you take a look at the graph, I typed it in Desmos, I got those 2 x-intercepts, and those are the answers, negative 2, and 16. Those are the answers that we got right there, negative 2 and 16, right? So that's because your discriminant was positive. It will cross at 2 locations. It'll have 2 answers. It'll have 2 x-intercepts. This next one, number 3, the discriminant was 0, which means you only have 1 answer. What does that mean visually? That means that it touches. It doesn't actually cross through the x-axis. It only touches it at 1 spot because there's only 1 answer. After all, x-intercepts are the answers. And lastly, if your discriminant is negative, how do you think that's going to look? Well, I already know the parabola is opening down because it's negative. I know it's not going to cross the x-axis because I don't have any real answers. They're imaginary answers. They're not real. And if there's no real answers, then that must mean that there's no real x-intercept. So here's the graph. It's opening down and it doesn't cross the x-axis, okay? So yes, you could use Desmos on some of these to find the answers. So if I asked you to solve number 2, you could have graphed it on Desmos and saw that it crosses at 16 and negative 2 and you got the answers. You could have graphed this one on Desmos and you see it only touches at 2. But when you graph this one on Desmos, you see that it doesn't cross, so you're stuck. You have to be able to simplify this and get imaginary answers, okay? But anyways, that was all based on the discriminant, and now we could actually conclude this final part of the lesson. It says that you could see on questions 2 through 4 above, you may have 2 real answers, 1 real answer, or no real answers, which means imaginary. Knowing how many real answers is easy to determine based on the discriminant, the inside of the square root. If the inside of the square root is any positive number, anything greater than 0, then it's going to have 2 real answers. We already saw that on question number 2 above. But if your discriminant is equal to 0, then you're going to do the square root of 0, and it doesn't matter if you add or subtract 0, you're only going to produce 1 real answer, which only has 1 real x-intercept, 1 real solution. And if your discriminant is negative, in other words, if it's less than 0, if it's negative, you can't do the square root of a negative that produces I, that produces imaginary values, then it's only going to have, oh wait, that's a typo. It's going to have no real solutions. Man, sorry about that. No real solutions. So if you guys understand what I'm saying here, you guys should be able to conclude this final question. How many times will that parabola cross the x-axis? Or I could also ask, how many real solutions does it have? Or how many real zeros? How many real roots? I could ask all those different types of questions. It all means the same thing. So you don't have to find, so keep in mind, you don't have to find the answers here. It doesn't say solve. It doesn't say find the x-intercepts. It is simply asking how many times will it cross the x-axis? That means it might cross once, might just touch at one spot, might not cross at all, or it might cross at two spots. Those are the only options, right? A parabola can only cross at two spots, or maybe just touch at one spot, or maybe the parabola doesn't cross the x-axis at all, right? So you may have one solution, two solutions, or no solutions crossing through the x-axis. So all you got to do is think about the discriminant, the inside of the square root. So if you understand that b squared minus 4ac, if that's a positive number, then you're going to end up with two answers. If b squared minus 4ac is a negative number, you know you can't do the square root of a negative. You end up with no real answers. But if your b squared minus 4ac is 0, then doing the square root of 0 doesn't change anything, because you could add 0, then subtract 0, and you only get one answer. I hope that makes sense after this long lesson. So let's actually find the discriminant here. The discriminant, b squared minus 4 times a times c, where your b value is negative 6, your a value is 1, and your c value is 10. So negative 6 goes inside the parenthesis, minus 4 times a times c. You could use a calculator, or you could do it in your head. Negative 6 squared, negative 6 times negative 6 is 36. 4 times 1 times 10 is 40, but of course there's a minus sign in front of it. 36 minus 40 is negative 4. So the discriminant is negative 4. So how many times will this parabola cross the x-axis? 0. That's exactly right. Because if you were trying to find the answer, this would be inside your root, and the square root of a negative is imaginary. So if you have imaginary answers, that means you don't have any real answers, which means that you don't have any real x-intercepts. So it does not cross x-axis, right? There are no x-intercepts. I guess it says how many times. You would say 0 times. 0 times. It doesn't cross. Okay, so there will be a couple of questions like this on our next assessment. I hope you guys now understand the quadratic formula and the discriminant, which is in the quadratic formula.